Any questions before I move on to the next bit about response policy zones? I think, Rabin, you had a question, right? Yeah, please.
My question is that are there any web interfaces or I can connect um, to my zone file every time opening the zone file using the VIM, it's some hassle. It might be some wrong. So to minimize that hassle, are there any interfaces or API we can connect?
Okay. So the question is actually on a different tangent in comparison to what I'm talking about, but I'll still answer it because that's, I think, operationally a very valid question. One of the ways in which, so I'm not suggesting anything here, I'm just giving you certain insight into what can be done, right? Whatever works for you, feel free to do that. So one of the options you have is to basically use Power DNS. So Power DNS has an option to use MySQL as the backend database, right? So instead of flat zone files, Power DNS authoritative has the option to use MySQL, right? So you could then build a dashboard for the MySQL database or an API, right? A middleware API and then a front end to it. And there are a lot of, I think, PHP scripts available for doing that. So that is an option that you can typically explore. The other bit of advice that I will also give is, and this applies not just to in the context of response policy zones, but generically as well, is to use Git, right? Git is basically used for version control. So anytime you make a change, you notify or you update Git saying that here is a file that I've changed. So what is the advantage of doing this is you will have a trail of you know all the changes that you have made, and you don't need to typically you can go back in time, right? Let's say, for example, yesterday evening you opened the unbound.conf or the zone file and you made a change to it, right? You saved the file and you reloaded the name server, and then today morning you realized whatever change I made yesterday, I want to roll back. I want to remove the change, right? One, if it is you alone who is managing the DNS infrastructure, then you would probably have an understanding of what change you have made, right? But let's say there is a team of multiple people, more than one, who are managing the DNS infrastructure. Now they would not know what change was done, right? So rolling back is going to be, unless they speak to you, communicate with you, they're not going to know what change was done to roll back, right? So the alternative is, if you're using Git, which is actually typically used in the context of software development life cycle, right? When you're building a software. But I would urge network engineers, network operators, system engineers, system administrators, basically anyone who is working on a computer, right, in the technical side of things, to learn Git, right? So it's version control. So every change you make gets stored inside a database, which is its internal storage, and you can roll back. So you can basically, let's say, for example, Rabin, you made a change yesterday evening, and tomorrow morning I come and I say, oh, there is something not working. I can, without communicating with you, look at the Git log, find the change that you had made, roll back, right? And that's very powerful, right? So it's a different concept. It's ideally used in anyone who is building software per se, but I would strongly urge people to actually learn Git in the context of, because as network operators or network engineers, we work with configuration files a lot, right? And having a history of all the changes that we have done makes life a lot easier, right? and rolling back becomes easier. Otherwise, people follow that method of, if the file name is unbound.conf, unbound.conf.backup, unbound.conf.latest, unbound.conf hyphen 25th November, February 2025, like create hundreds of backup configuration files, which basically doesn't serve the purpose, and it is not scalable as well, right? So I hope that answers your question. You can explore Power DNS with MySQL as the backend database, and then build an API or a front end to it using PHP or React or whatever, right? And use Git, irrespective of whether you use a database or not. You use Git, right? All right. Any other questions before we move on? Okay. So as I was saying, this is the response policy zone format. So ignore what you see on the right. So there is a semicolon, which is basically a comment, right? In a zone file, when you're commenting, it starts with a semicolon, right? So this is a zone file from a threat intelligence source, which is OSINT, called as URL host, right? If I search for URL host DNS RPZ, the first link that shows up is going to be that one, right? And it talks about how to configure it, but I'm going to skip that part and go directly to the URL. And this is that URL, right? So the idea here is to, and I'm going to only focus on OSINT, that is open source intelligence. I'm not going to talk about, as I said, proprietary threat intelligence providers. That's not the something relevant to my topic today. So this is one of the source, right? Credible source for malware domains and C2 domains. Okay. So this is an open source intelligence platform where a lot of security and threat intelligence provide, or other threat researchers share their research for free. So how do they do that? They will once they get an access to a malware, they will reverse engineer it, find out all the domains that it is connecting to, and then log in into the URL host portal. Anyone can create an account and submit those domains and say, this is this particular malware family, this is this malware family, and so on, right? So you can take this zone file and just plug it into your recursive resolver to block threats pertaining to not all the threats in the world, but whatever is being found and is being searched for. So as an example, here is, I'll take one domain. Okay, this is going to be fun. So what does it want me to do? Please try again. Okay. Stuff with wheels. Okay. I need more coffee. Thankfully, it worked. So there is a particular domain name, as you can see, avastng.com. That's a very interesting one because Avast is an antivirus provider as well. I think the domain name is avast.com, if I'm not mistaken. Don't take my word for it. But this domain, there are multiple providers here which are talking about this particular domain. And it was first seen on 30th December 2024. It's particular pointing to a particular IP address, AS or other AS autonomous system, AS 198.953. And it is distributing an APK, a malware ridden APK, right? So maybe something to do with banking Trojan or maybe spyware, right? So it also classifies the tag called as spy note. And who has shared this. I think there should be details about somebody who has shared it. Should be somewhere here. Here it is, reporter. So there is a threat researcher with this particular handle who has shared this domain name, these artifacts, right? So it's very exhaustive. You can actually go through it in detail. But then again, I would also urge you to don't take it as a source of truth, because if there is a threat researcher who mistakenly, right, or intentionally puts valid or legitimate domain names in that data set, right, there could be false positives, right, and that will hurt from a business perspective. That will hurt from a operations perspective when things will stop working, right? If they don't resolve, then it'll be a big problem in the network for users, right? So one of the ways you can do that is, if this is a list of all bad domain names, then rather than taking it and just plugging it into the recursive resolver, what you can do is you can create your own whitelist, right? A list of all domain names, which are legitimate domain names or domain names which are being used internally for banking, for any other purpose. And you could, uh, sort of do a negation, check if there is any domain name in this particular response policy zone file which is containing legitimate domain names that are being used in the network, right? And then negate those from the source, which is the response policy zone, and then block it rather than directly taking it and blocking it, right? All right. So the next thing what we will see is, if I am still connected. Thankfully, I am. Okay, let me see. So I'm using Unbound as the recursive resolver. So just a heads up, this is a 1 day hands-on workshop, right? So what I'm doing here is typically going to go, a little more on the practical side of things and show you how it is configured, how it is to be done. But this is actually a 1 day hands-on workshop, and you know, I'm not going to be able to cover everything, but I'll give you a glimpse of what is possible. So you can do this at your end. I'm not going to set up Unbound here because it's already running, it's already set up. But if you want, I can probably show it later once we are done at 1 o'clock, right? I can compile and run Unbound and show you how to configure it. So this is a default Unbound configuration file. My apologies. That's my firewall telling me something has changed in the network and it's trying to connect. All right. Ah. So what I have here is in Unbound. This is the important part. I'm loading that particular module. These three are the ones which are primarily required for response policy zone. So depends on how you are installing the recursive resolver, right? Irrespective of whether it is bind, Unbound, Power DNS, or not DNS, whichever you are using, the response policy zone might not be enabled in the software if you're using a package manager, right? So you like the package manager like apt-get, right? Or yum in a Red Hat based distribution, it may not have response policy zone enabled by default, right? And one way to do that, I'm sorry, one way to do that is to compile and install the recursive resolver from source, because that gives you control on installing it, and you can also define what parameters you want to enable, what parameters you want to disable, right? So just to give you a heads up, so this is the source of Unbound version 1.20.0. I think the latest is 1.22, if I'm not mistaken, but whatever the version is, right? And the way to install that would be to use the configuration. Yeah, that would be the configure statement, right? So when you use that configure, of course, there are a few additional elements here, but this would be the configuration, the configure statement in order to configure Unbound on the system with the response policy zone support. Do do people want me to do that? Do people want me to actually install Unbound and configure it from scratch, or is it okay if I can proceed with the response policy zone configuration? Okay. Sorry? Okay. All right. So I'm going to skip that for now. So the basic principle behind response policy zone is it's like a typically like a firewall where you have a trigger and then you have an action, right? So as an example, QName stands for query name, that is the domain name. Then if there is this domain name matches in the query, then what are the different sort of actions that are possible, right? I'll skip a few right now. I'll not go into detail, but I talked about NX domain, right? That is the lying that I talked about. I want my recursive resolver to lie to the endpoint saying this domain name does not exist, right? Then I can drop, the recursive resolver will not respond at all. It will drop the packet. It is not going to respond back with a response, right? There is a problem with that approach because I don't tend to use the drop method because the the endpoint will keep on sending that request again and again and again, right? And that will flood the recursive resolver. So depends on certain use cases. The other interesting bit is pass through, that is allow, right? But I can log it. So let the domain resolve in the network, but log it to a log file, right? So I can configure that. And then there are a few other options which I'll skip for now. Then I can do based on client IP address, like who is asking the question. In my network, if this MacBook is asking the question, then do this, right? If it is Gabriel's laptop which is asking the question, then maybe do it differently, right? Or I can do it this way that if Gabriel is making a DNS query, then none of his all his DNS queries are going to get logged, or all of his DNS queries are going to get blocked, right? So that is the level of control that is possible, right? Based on the client IP address, the source. Response IP address, right? So when I say response IP address, it is the response IP address in the DNS payload. So when the response is coming to the back to the recursive resolver, based on the IP address, we can have an action, right? So if you have a list of bad IP addresses, okay, you put it in the zone file, and then you use this method, any domain name pointing at that IP address, block. Even if you don't know the domain name, right? You can block those domain names. Like one source of intelligence, which is again OSINT, is the spamhaus drop list, right? Drop stands for do not route or peer. And this list is available for free, right? Again, wet the OSINT or open source. So this is available for anyone to use in the network. And if I open the V4 list, then it is going to be in JSON format containing the CIDR. There is an ID or a reference, and then the RIR, where the IP address is assigned or allocated, right? If it is APNIC, if it is RIPE NCC, or whoever it is. So this is an excellent source for plugging into a recursive resolver using response policy zones, right? So any domain name on these IPs, I may not know the domain name, but using the response IP address logic, I can block all those domains. And one background behind this is the do not route or peer is this is the baddest of bad IP addresses on the internet as per Spamos, right? So whatever badness they see in terms of intelligence, this is the baddest of bad IP addresses. So similarly, they also have something called as an ASN drop, right? This is a list of all bad ASNs from where a lot of badness is originating. But this you cannot plug it into a recursive resolver because there is the ASN name or something is something that you cannot use. I'm just giving you a reference saying that this is again a source of intelligence elsewhere, right? Similarly, similar to the response IP address, that is the IP address in the R data field, right? You have something called as NSIP, which is a name server IP. So if I may not know the name servers, but if I know the IP address, the same concept, I can take the drop list and I can say any domain name where the name server IP address is in that list, is in that zone, right? Block or log or pass through, whatever, right? I can define whatever action that I want to do. And the fifth one, the most the treasured and favorite of mine is the NSD name, which is any name server. You create a zone file, put all the name servers which are bad, right? And doesn't matter what domain names that those name servers are using, right? So even if you don't know the domain names, because the name servers are in that zone file, you can now define whether to block, whether to log, or whether to drop it entirely, right? So this, in my opinion, is very powerful. Now, interestingly and unfortunately, you will not find threat intelligence sources, at least OSINT, which will share bad name servers on the internet, right? They will either share the IP address or they will share domain names, right? But you can actually, if you have people working on the security side of things, they can identify name servers based on domain name data, right? So if you take URL host as the database, if you find all the name servers that it is using, you will come to a pattern that these are the name servers which are being used in most of the infrastructure, right? Now you plug that into a zone file and you can block that as well, right? So you see this is very powerful. In fact, this is mentioned in the IETF draft for the particular trigger, which is NSD name, and that's the example. So let's say, for example, ns.example.com is a bad name server, and I want to block it, right? So I'll create a zone file, and I'll put ns.example.com dot the trigger, and then what I want to do is I want to block it. So I say cname dot, right? Cname stands for canonical name for or another name for. Dot means give the response nx domain. So it is not going to resolve that particular or any domain which is using that name server is going to get blocked in my network. So that's super powerful, right? You identify domain names which are bad. You identify name servers of those domain names which are being used by these malicious domain names. You plug it into a zone file, and that's going to block all sort of badness. Now here is a catch. Don't put shared hosting name servers in that zone file, right? Put name servers which are typically dedicated name servers that the threat actor is using. If you use something like, let's say, Hostinger name servers, right? Hostinger is a web hosting provider that I'll take as an example. And if you take ns1.hostinger.com, ns2.hostinger.com, and you put it here, you're going to block probably bad stuff, but you're also going to block legitimate stuff as well, right? So that's not going to be a good idea. So make sure the name servers that you're going to put in the zone file are name servers which are, 100% bad, right? And typically, when you analyze, you'll understand based on passive DNS analysis, like which are dedicated name servers and which are shared hosting name servers, right? Any questions? Okay. So let me go back. Was there a question? Okay. Right. So what you see here is I have 3 response policy zones defined in my recursive resolver, right? Um, the C1 Black, which is the ads that I talked about, right? Then I have URL horse as well, right? And then I have Circle as well. Circle is from Luxembourg, right? And they provide access to a MISP instance, which is MISP is basically a software which is open source for threat intelligence sharing, right? It's very widely used amongst security teams and also used by a lot of certs and CSerts, right? So MISP has an instance, or other, when you install MISP, you get a public feed, you get a community feed. So you could export that as an response policy zone, right? So if you set up MISP locally or in a VM as well, you don't need to install put it in production. You get a community feed, right? But one word of caution: be very careful in terms of, as I said, OSINT or community feeds. There can be a lot of false positives sometimes, not just in Circle's feed. I'm saying generically. So you can export all the threat intelligence data from MISP, right, into an RPZ format, right? So the software for MISP is available at misp-project.org, and it's open source, right? You can try it out on a VM. You can put it in production. We use MISP extensively in terms of our threat intelligence pipelines. So all data finally comes to MISP, where the analyst is actually analyzing that data and adding correlation or adding context. So very powerful, and it has a correlation engine. It has a lot of things you can do in terms of MISP. So why this is useful is because in security, right, one of the major challenge which exists, not always, probably I'm generalizing, is there is a lot of malicious activity happening on the internet, right? But you will see some activity in your geography or your constituency. I will see something, but there is always something overlapping. Always these attacks have some pattern or commonness to it, right? The sharing of intelligence is extremely important, right? Like I share what threat intelligence that I am gathering or correlating or curating with you, and you share what you are. What that does is we help to protect each other, right? Because there might be some sort of an attack which I am seeing, which is probably not having, which is not happening at your end today. But tomorrow, you will probably see something very similar, because these threat actors tend to, share these. In fact, there are marketplaces where phishing kits are sold. Same, these control panels which are being used are being sold, or sometimes even put out for free as well. So it is extremely important to share threat intelligence in terms of what we are doing. So MISP is an excellent piece of software to do that. There are a couple of others as well, but MISP is something that is primarily used in industry. Okay, going back. So this is what I have. So MISP provides you that. Then the Stephen Black, I talked about Script Tiger, the website Script Tiger. There is a zone file. So you download that, and then that goes there. And then there is a URL host response policy zone, right? So I'll quickly show you a demonstration of how this works. I'm not sure the data is latest at this point of time, because this is an instance I'm running on the cloud, which has not been updated with these zone files. So what I'll do first is I will download the latest source of threat intelligence, which is Stephen Black response policy zone and URL host, and update it. Then I'll start the recursive resolver or reload it if it is not running. Then I'll query for a few of the malicious domain names which exist in those zone files, right? I'll also query for those domain names outside of this. So I'll send the query to 8.8.8.8, and I'll send the query to the recursive resolver that I'm running, and you'll see the difference, right? In fact, the two of them are actually getting updated pretty much every day. So the timestamp tells me that 6:30 Indian Standard Time, Stephen Black, that is the response policy zone for ads, has got updated. 9:25 earlier today morning, that 10 minutes, yeah, so it's 9:35 in Indian Standard Time. So 10 minutes ago in IST, that has also, URL host has also got updated, right? All right. So if you see, what I've done is I've taken one of the domain names from, uh, where is, here it is. Okay. So I've taken one of the domain names from a response policy zone file, starcountry.net. And as per URL host, it's propagating malware, right? So you see the comment. It's pretty, actually, it's pretty old. 26 May 2019, right? So it's a pretty old one. That's an interesting one. Irrespective, maybe it has been taken down, maybe it has not been taken down. Irrespective, it is still pointing to an IP address. So usually, sometimes law enforcement will sinkhole the domain name. That is, they will not take it down. They'll not suspend the domain name. What they'll do is they'll sinkhole it. And why they will do that is because they want to find out the victims so that they can notify, like, there is malware in your network, right? So they will do a process called as sinkholing. And that process involves changing the name servers of the domain to name servers which are being controlled by the law enforcement agencies, right? So in this case, maybe that's the case because the domain is very old, but it is still resolving. Now what I'll do is I'll see if my recursive resolver is running. All right. So when I checked, Unbound was not running, right? Because as I said, I'm not using this Unbound on this particular cloud instance. And then I have started Unbound, and you see the process Unbound is now running on the server. So what I can do is I can query for the same domain to the recursive resolver on that system, on that server. I'm getting a response, which is interesting. Ah, interesting. So I figured out what the issue was. Sorry. Yeah. So I don't know where I had picked up starcountry.net, but interestingly, was that on the, let me see if it is here. Yeah. So I don't know where I had seen only the domain name. So the www was, did I miss that part somewhere earlier? Let me see. Anyways, I think I probably missed uh, the entire subdomain or entire domain name. So the domain name that is in the list. So this is actually a good um, issue, because this tells you that it is blocking exactly what is there in the zone file, right? So if I want to block anything under that domain name, I need to write the entry separately, right? So I'll do that. But what I meant to say is the reason why it did not block earlier and why it is blocking right now is because earlier I had only given starcountry.net, right? That doesn't exist in the response policy zone file. What exists is www.starcountry.net. So you see, when now I'm making that query to the recursive resolver, which is configured with response policy zones, it is giving the response NX domain, non-existent domain. Lying, it's actually lying, right? That this domain doesn't exist on the internet. But in fact, on the internet, this domain exists. Or other, when I say exists, it is resolving. Sorry. So when I do this on, so here, when I send it to Google's DNS resolver, 8.8.8.8, that domain is resolving, right? You see the answer, 219.79.210.219, right? But when I'm doing the same thing on the system which is running my recursive resolver with response policy zone, you see that domain is not resolving. It's a NX domain, right? And if I check the log, oh, I'm in the wrong directory. This is called as problem is between computer and chair, right? Of course, you see RPZ applied, Stephen Black. This is the name that is there in the unbound configuration that I've defined. This is the domain name. And what is the policy that has been applied? CNAME dot. So it is RPZ-NX domain. That is what it stands for. So the log file will also give you the telemetry or the visibility whenever an action is taken. Of course, you can configure this differently. And I wouldn't, ideally speaking, as a best practice, not to run or enable the log on a recursive resolver which is high transactions or where number of clients or number of queries are more, because the log file is going to slow down your, from an operational perspective, slow down the recursive resolver, right? So technically speaking, logging is okay when you are having a small environment where number of queries are less. But when you enable logging on environment where number of queries are high, the log is basically going to be a bottleneck for the recursive resolver software, because that is going to do a constant read write, right? So the disk IO is going to be very, very large, right? Constantly read write, right? So that's going to slow down to a certain extent the recursive resolver. So the alternative to that is to use a piece of software called as Zeek, right? ZEEK, which is actually a passive network security monitor. But I tend to use Zeek for passively logging data from a recursive resolver, because it doesn't meddle with the recursive resolver at all. The recursive resolver will continue to do one job, which is recursion, and Zeek will passively tap into the network interface and log into a file called as dns.log, right? So that's something that you can explore from a production standpoint, right? But any questions? I hope you got the idea about response policy zone. Yes. For what? Dynamic DNS?
Yeah, does it work for DNS over TLS as well?
Okay. Is your question, will response policy zone work if your recursive resolver is doing DOT? Is that what your question is?
To some degree, but the challenge we are facing with some DNS products right now is that the hosts, even with the GPO applied and everything, the policies implemented, the hosts are directly reaching to OpenDNS and Google inside the Google Chrome over TLS.
Right.
So they are not talking to my DNS
Local
resolver.
DNS.
So yeah, that's the question.
Okay, understood. So that's a interesting bit, because if your packet is not going to reach your recursive resolver, then your recursive resolver is blind, right? It cannot do anything about it. And that is sort of a policy question now. Do you allow endpoints to bypass your security controls, right? Do you allow your endpoint or your devices to communicate with maybe open resolvers? Now that's an interesting thing. Now I'll slightly pivot to a different angle. What if there is a malware, and there has been malware which is running its own DOH server, right? DNS over HTTPS server. Godlua is one of the malware variant, GODLUA, right? And that is a malware which directly connects to a DOH resolver endpoint, which the threat actor is controlling, right? So where do you draw the line, like this is legitimate and this is not? So this actually falls under sort of a, from a policy perspective, block everything which is not, so basically my network, my rules, right? So anything which is not following my rules, I'm going to block it, right? So enterprises would typically want to do that, right? Um, a network operator cannot do it, right? A network operator basically is neutral in a sense, and network operator is primarily interested to maybe understand what sort of badness is originating from my network, right? But having said that, if a user, if a consumer of a network operator is using DOH, then you lose visibility, right? Your traffic, your DNS traffic is going, the users DNS traffic is going to go through a tunnel, a TLS tunnel, and that is going to be similar to what HTTPS traffic is. So you're not going to see anything of that sort, right? So there might be badness originating from your network, but you have zero visibility over it, right? So as a network operator, in my perspective, you do not have any control over it, right? Now, of course, there might be network operators, and I'm sure there are network operators which are bad, like the drop list, which are probably doing man in the middle in all sorts of ways and hijacking a lot of traffic, not just DNS traffic, a lot of other traffic of users as well, right? Now that's a different story. But as a defender, I don't think as a network operator you can do anything about it. That ship has already sailed, right? RFC 8484 changed everything. DOH is here to stay, and you cannot unwind it now, right? As an enterprise, if you're managing, say for example, an enterprise network, then there are ways to sort of put a policy control, which is also getting difficult with your TLS 1.3 and so on. But still, there are ways to put controls wherein if there is traffic going to, let's say, DOH resolvers, I can maintain a list of all publicly known DOH resolvers and block access to those, right? But then again, there is a blind spot there. The blind spot is publicly known. Threat actor is not going to put that his DOH resolver in that publicly known list, right? So a lot of times I find people defending, I'm blocking DOH. That's not possible, right? I have a list of all DOH resolvers which I'm blocking. That is not possible. Threat actor is not going to advertise their DOH resolver to you, right? Unless and until somebody, a threat researcher or a threat intelligence company or somebody who is investigating stumbles upon that DOH resolvers and attributes saying that this is malicious activity going to that DOH resolver, that's not possible, right? So different use cases depending on which side of the table you are sitting at, right? But yeah, it's getting difficult in all sorts of ways, right? But aside from that, unless DOH is or DOT is a lot easier to block because it's at a known particular port. Aside from that, there is a lot of still DNS chatter or communication or telemetry which is happening on DO53, right? So even though DOH has been in existence for some time, there is still large amount of telemetry which is on DO53, which is basically, in my opinion, a gold mine from a defender's perspective, from a threat hunting perspective, or even from a incident response perspective, because you get the ability to identify and know what sort of anomalies are happening. Like as an example, number of DNS queries. Like I'll give you probably certain methods, just top of my head. Amount of DNS queries happening, sampling on per day basis, per week, per month, and so on, right? Amount of DNS queries which were NX domain. That's a very interesting insight to look into, because that is pointing at anomalies straight off the bat, right? If you have any or large number of NX domain queries in your network, I would say you need to investigate them, because that basically says there is something, some endpoint in a network or endpoints which are trying to resolve or communicate to domain names which don't exist, right? And that's an anomaly to also begin with in from an investigation perspective. So there are many ways in which you can still leverage DO53 telemetry in pertaining to any sort of badness happening in the network, right? Any other questions? Yes.
As you had shown that you pointed the www.starcountry.net aligning to dot. Can we use some regex or wildcard in that domain?
Not in the zone file. So if you're saying, can the source have a regex pattern, right? Not in the zone file. The zone file should contain, so it's as your authoritative, whatever rules apply to a zone file of an authoritative name server, right? Same rules apply to a response policy zone file, right? So that doesn't change. Only thing what you're the functioning is different. The zone file in an authoritative is serving authoritative answers. The zone file of a RPZ is serving lies, right? That this domain does not resolve or doesn't exist.
Oh, I just volunteered to hand over the mic.
Thank you so much.
But yeah, since you say you're looking at me, I'll just comment on the previous question. Is that the internet domain name is not only used by their users but also machines. A lot of machines use it. So for the users, DOT and DOH is more appropriate. But data centers, their servers are compromised and communicating to many domains. This can be useful for those devices and systems that will not by themselves will be able to establish a TLS, a connectivity, or HTTPS connectivity. Yeah.
And also the fact that to add to that is setting up a DOH server involves doing more rather than DO53, which is easy, right? Use the shared hosting authoritative name servers, or use dedicated name servers using bind or your Power DNS or whatever, right? That's very easy to set up, right? Just an Ansible playbook and you're done. DOH is involving more, not only for a user, but even for a threat actor. They have to set up DOH resolver using Unbound or whatever, set up a TLS certificate on that. They need to get a TLS certificate on for the domain that they are configured as DOH, right? Which means there is also a footprint that they're going to leave in the certificate transparency logs as well, right? So whenever a TLS certificate is generated, the entry for details metadata about that TLS certificate are going to go in the certificate transparency log as well, right? So a trail is left. Not necessary that anything that is showing up there is bad, but definitely a trail exists, right? Yes.
Yeah, if it is enough, if we block all the DNS query to outside of the enterprise at the firewall level and enforce all the DNS query only to the specific number of
To the
DNS
recursive
query.
resolver, you
Yes.
mean? Yes, absolutely. That's something that I would recommend. Where, but then again, it's a little complicated answer. So one thing you could basically do is this is in the context of an enterprise network, not from a network operator perspective, because there is net neutrality at play in many geographies, like in India as well, right? So in an enterprise network, one of the best practices, redirect all DNS queries to the recursive resolver. So one single rule at the gateway, at the firewall, any DNS query originating from my network, which is not going to my recursive resolver, forward it to the recursive resolver, right? So if a user is setting 8.8.8.8 on the endpoint, the packet will first hit the gateway, right? So when it goes to the gateway, the rule matches, and then that query is forwarded to your recursive resolver. Now, this is only in the context of an enterprise network or a home network, right? For a network operator, pretty much you don't have control over what the user is going to set, right? But that is something that would be recommended, because otherwise users would bypass your recursive resolver entirely, right? Yes, yes.
If your devices in your enterprise is affected by the virus, so you are ended up forwarding a lot of traffic to the your DNS, that can cause also problem. So if it is not better to just block it on the firewall.
Interesting point. So if you are blocking it, then you're also going to block legitimate traffic as well. Like let's say a user sets 8.8.8.8. Understood. But let's say, for example, aside from in a very large network, like let's say, for example, yes. So you're going to also put a lot of strain on your support staff, where probably users are going to complain that internet is not working the first time till they understand that they cannot use 8.8.8.8 or whatever DNS that they're using, and they need to compulsorily use your DNS, which is being pushed via DHCP or statically assigned by the user, right? If you want to eliminate that, forwarding becomes an easier option, right? Because without causing an inconvenience to the user or to the support staff, you are getting the DNS queries, internet would work, but you will also get the visibility, right? I'll give an example. In India, a mandate from the government kicked in where all organizations, irrespective of size, have to maintain logs for at least some period of time and report a security incident within certain time frame, right? Now, this applies even to universities, enterprises, even a startup with one person has to do this, right? Now, if you're not having that visibility of your DNS traffic, if there is some incident that happens, without that visibility, you cannot trace back where it originated from. So forwarding becomes an easier option on both sides, reducing the burden on the support staff, where people complain without using my local DNS, internet is not accessible. At the same time, your users will still be able to access, and you will be able to block threats at the response policy zone level, right? I hope that answers. Any other questions? Yes, Champika.
Yeah, coming back to that earlier discussion, we could still use, I mean, say a threat actor, they could still use encrypted SNI, right, to hide themselves.
Yes. So I also mentioned TLS 1.3, which is encrypted SNI, which is making more difficult in terms of using DNS telemetry, right? So for that, you have TLS fingerprinting, nothing to do with DNS, but TLS fingerprinting, which is the JAR4 framework, right, is something that um, you know anyone who is profiling or monitoring threat actor infrastructure, that's the only way to go about it. because it's getting more difficult in terms of visibility.
Okay, good. Thank you.
So JA4, by the way, is a library. It started with JA3, right? But now I think the newer version is JA4, and there are many variants to it: fingerprinting clients, fingerprinting servers. So the libraries are open. I don't think you can use it commercially in a product. You need to take a license from the creator, right? And if I'm not blanking out on his name, Atkins, Josh or something. I'm probably need more coffee. But that's an excellent framework for or a toolkit for profiling TLS sessions, right? So you could fingerprint control panels or command and control servers using that particular framework, right? Now it can be done passively and it can also be done actively. And a lot of these search engines for security researchers and threat intelligence like Shodan, right, or Census, have added the capability to profile using JA3, right, or JA4 now. So that also exists. So that's another. So you only had IP addresses, domain names, hashes. Now you also have TLS hashes as well, right? So that's another indicator from a threat intelligence perspective that you can block in your network. So I think I have already covered this part. So here is a snippet from a DNS response policy zone or a protective DNS server, which is blocking, I think, only a domain name, indianlife1.com, because it is in it's a newly registered domain name. So you see, you can also customize that part. Newly registered domain name, 1 month. So you can add verbose logging, like you can assign threat levels to it. You can do all sorts of things. You can also do something like a captive portal, right? Or not captive portal, I'm sorry, a walled garden, right? So say, for example, user accesses a phishing page and you want to educate the user saying that this has been blocked because this is bad. So you could set up a web server with a walled garden page, static page, saying that this domain name has been blocked because it is malicious, right? And you can add that in response policy zone in the trigger part, or in the rather the action part, which forwards that to DNS traffic to a walled garden page. Rather, not the DNS traffic, but it forwards saying that this domain is pointing to this IP address rather than the actual IP address of the domain. So users, so this is typically what you see in the safe browsing project by Google, right? You see that red screen. If you have ever accessed a malicious domain name, you will see a dark red screen. You know, website has been blocked for harmful reasons or something like that. So that's very similar to what you can also do with response policy zone. Now here is an interesting part that will work only for phishing domain names, right? And that will not work for domain names which are being used by a malware for command and control, right? Because they are happening behind the scenes. There is no HTTP traffic there typically. That would be exfiltration of data, or maybe just sending off traffic like a beacon to a domain name which is being controlled by the threat actor. So walled garden approach is not going to be helpful in the case of domain names which are not phishing, right? So you need to configure that. You need to configure that accordingly. I think the couple of additional points which I will point to is additional sources of threat intelligence, which is OSINT. OpenFish has a feed which is open source. I don't think this is the one. Yeah, this is the one. Yeah. So you go to openfish.com. Again, no affiliation to this project. This is They have a commercial side, but I'm talking about the free one, a community feed. It's updated every 12 hours. You can download that, and you need to change the format to a response policy zone format, because this is only URLs. So you need to extract the domain name from this list, convert it into response policy zone format, a single Python script, or any programming language that you are comfortable with. You can use that to convert it into a response policy zone format. And then maybe if you want, you can, I'll share my contact details. I have a script which I use to do the conversion. So I can share that with you if that is something that you want. So convert that into a response policy zone format and then plug it into your recursive resolver. One important point, this is going to contain a lot of false positives. This particular source is going to even contain something like sheets.google.com, right? Because this is URLs. And the fault is not with OpenFish, by the way. This is all URLs, right? So when you extract sheets.google.com, that's a legitimate domain name. You should not be blocking that, right? So you need to be very careful in terms of negating the good stuff and only taking the bad domain names and plugging it into your recursive resolver. This is one more source. The Computer Emergency Response Team Poland also provides a list, which is again OSINT or open source, which is primarily, if I'm specific, it's mostly phishing domain names targeting users in Poland, right? So you could also look at that particular list. Not necessary that it is going to be relevant to threats in your geography, but you can have a look at that. So there is a response policy zone format. So if you click on that, I think that'll open. Yeah. So that's, so they have interestingly a lot of domain names, and if you see, they are using the walled garden approach. So they have set up a domain name whole.cert.pl, right? So that's the walled garden page. Instead of only a dot, dot would mean it is going to respond with an NX domain, right? So that is going to show up in the DNS query as well when the client or the endpoint is going to make a request, and that will help the user in understanding as well. So you can have a look at that source. And I think there was one more. Let me check. I actually blogged about this quite some time back. Yeah, Stephen Black, URL host, cert.pl, and there is another one which a good friend of mine runs, Peter, for advertisements as well, and that's the list. So on my personal blog, brainattic.in, there is a blog post that I've made which is listing the open source intelligence response policy zone feeds that you can integrate, right? There are four of them that I've listed so far. You can have a look at that. I think in a nutshell, my feedback or my suggestion or my advice would primarily be to take control of your DNS, not just in the context of an enterprise, but also in terms of DNS queries originating from your devices, right? And you'll be amazed to know and see the sort of DNS traffic that is going to a, to maybe a cloud provider, right? And if you don't want to run a full-fledged recursive resolver, then you can also configure this project called as Pi-hole, right? Which is not response policy zones, but the idea is simple: to basically block ads and block all sorts of domains which are maybe malicious. And it has a web interface. You can install it on a Raspberry Pi, or you can host it on a cloud server as well, right? So I used to run this quite some time back, but in my opinion, the response policy zone is more powerful than a pi hole, because the pi hole can only block what it knows, right? Response policy zone can block even if it knows only a little about that activity, like a name server. You can block all domains which are being used authoritatively by that name server, and that, as I said, is very powerful. And then for remote access, you can explore. There are many options, but OpenVPN exists. But I prefer to use WireGuard, because not only it is open source, the the memory footprint is also very low, very less. So I run it sort of 24 by 7 on the phone. So all my DNS queries, all DNS traffic from the phone is actually being tunneled inside a WireGuard session to a cloud server that I operate, right? And the best part is the battery consumption is never more than 1%, right? You try to do that with something like OpenVPN, and your battery is going to be drained out in a few hours, right? If not minutes. Aside from the fact that the phone is going to be very, is going to heat up, every now and then. So WireGuard works spectacularly, right? Because very low memory footprint and very efficient, uses UDP, but it sets up a tunnel where the traffic goes inside the WireGuard tunnel. So that is something that I would urge you to do. Lastly, I think before I end, as I said, we have at first, which is the forum of incident response and security teams, we have a DNS abuse SIG, which is a special interest group where I'm a co-chair, where we have created something called as a DNS abuse techniques matrix, right? In fact, don't actually look at the PDF. There is a much nicer version, thanks to Shoko from JP Cert, who basically she and her team have created a HTML version which is much nicer. I am not sure where that is. I think it's here. Here you go. Yeah. So this basically, although the topic, what I talked about in these two sessions was primarily in the context of domain names and threat detection and mitigation using response policy zones, DNS is much broader in scope, right? There are different sorts of DNS attacks, not just limiting to domain names. Like there is open resolvers, right? Which can cause a DNS amplification attack or a distributed denial of service attack. There is lame delegation, right? Then there is domain hijacking that I talked about, right? Like the domain shadowing attacks, and so on. So it's divided into basically three parts: detection, mitigation, and prevention. So for every attack, it talks about who, for that particular attack, who can detect it, who can mitigate it, and who can prevent it. And there are various stakeholders like registrars, registries, authoritative operators, recursive resolver operators, law enforcement, and so on and so on. So it'll give you a perspective depending on which side of the table you are. It'll tell you if this is an attack that you are seeing, these are the stakeholders that you can contact for detection, for mitigation, and basically for prevention as well. So that's something that you can explore. And I think that's it from my end. So that's my contact information in case if you'd like to reach out, get in touch. Um, I'm not so active on Mastodon these days, but email works. So if you have a question that provided you have a question at a later point of time, then I think email would be the best way to reach me. I'm on LinkedIn as well. And as I said, when I began the presentation, I talked about the DNS haiku, the poem, which says everything on the internet is a fault of the DNS. Hopefully, I have changed your perspective that it's not DNS, right? It's you, right? So hopefully you find more security ways to use the DNS in the context of detection and mitigation as well, using response policy zones. So any questions for me for what I've discussed so far? Are there any questions on the Zoom session? Okay. If
Yes.
yes,
Right. Just a quick question, since nobody is asking. So, did you measure or did you experience any delay in terms of responses from the users if it goes through a lot of checking from the RPC zone?
yeah. So one of the things from a production standpoint you have to take into account is all the content inside the response policy zone, similar to how it works in an authoritative name server, is going to get loaded in memory, right? It's not going to be checked on disk, right? So you need to have good chunk of memory if you are running a response policy zone, which are pretty large in size. Like some of the response policy zones that we have, they're like megabytes in size, right? 600, 700 megabytes, one single zone file, like millions of domain names, right? So if you are, the way to benchmark this is if you're running a recursive resolver with, let's say, X amount of memory, I would say a rule of thumb is depending on the zone files, of course, your memory size has to be upped by at least 3 or 4 times, right? So as long as you have good amount of memory in the recursive resolver, I think you are good to go. Aside from that, typically not much strain on the system, because memory is the one which is being going to be looked up for every query that is coming in, be it a domain name, IP address, name server, whatever is you have plugged into it. So memory would be the only thing that you need to look at, right? So on an average, 64 GB of RAM, right, is something that we have found as a sweet spot depending on the zone files that we operate. And those zone files are maybe around 20 to 25 in number. Some of them are very small, some of them are megabytes in size, like 600, 700 MB, like few of those, one or two. Rest are all basically zone files which are maybe 8 MB, 10 MB, and so on. So all that content from the zone file is going to get loaded in RAM. So that's the only consideration to take. But so you cannot run it as you are running it with whatever specs of the recursive resolver. You definitely have to take into account the size of the zone files.
Thank you.
Any other questions? All right. So I think if not, I'll be here till tomorrow afternoon at least. So if you have any question, find me and say hello. And I'm not sure if there is a way to collect feedback. Is Apricot doing any collection of feedback? Is there a process? My ignorance. Okay. Okay. All right. So bricks, bats, buckets, whatever you have, throw it my way. Maybe once we are in the hallway. But I hope it was useful, and hope to see you again, and wish you good luck with the rest of the conference. Thank you.